Welcome and thanks for attending today's Ask CTE Contributors webinar event on grinding. I'm Dennis Spaeth, the owner and publisher of Cutting Tool Engineering, and I'll be serving as the host and moderator for this one-hour webinar. Just as a reminder, today's webinar is intended as an extension of the feature article published in this month's issue of Cutting Tool Engineering. The article, titled Diamond in the Wheel, addresses the use of optimized single-layer diamond tools for cutting and shaping natural fiber reinforced composite materials, and was co-authored by Thomas Namola and Jeremiah Wolf, product development and applications engineers at Abrasive Technology LLC. CTE is honored to have both contributors joining us for today's webinar. Now I'm going to turn over the controls to Tom and Jeremiah, who will provide a brief recap of the article and expand on some of the elements discussed. Afterward, they will take questions from the audience. Hi, guys.
Hey, Dennis.
Thank you. Thank you for hosting this for us. As Dennis said, our topic today is optimizing a single layer diamond tool for cutting natural reinforced composites. We'll kind of go through some highlights of the article, start by telling you a little bit about myself and Jeremiah and a little bit about Abrasive Technology, and then we'll get into the article overview. So I've been with Abrasive Technology for a little over 37 years, worked throughout the organization in engineering, manufacturing, and R&D, done various grinding projects, and have been in this role as product development and applications engineer for about the last 14 years.
Jeremiah Wolf, and I've been working at Abrasive Technology just under 6 years. Prior to that, I spent time working in machine shops, doing general machining, some programming. Got into a couple of different companies working in product development, product testing before I came here, and just over 1 year ago transitioned into product development and applications after working in our manufacturing engineering side.
So a little bit about Abrasive Technology. We've been around about 52 years. We have always been a super abrasives company. So we deal in diamond and CBN, multiple ways to bond those two materials. Single layer, which we'll be talking about today, which is brazed and electroplated. We have resin hybrid metal bonds. We also make PCD and PCBN fluted tools. So basically we specialize in super abrasives and we specialize in custom tool design. Not a catalog company that's gonna say, oh, there's your application, go to page 3 and buy this tool. It's more we wanna collaborate with you, work with you, understand what your goals are in your application, and then design a product that meets your needs. As you can see by that last line, we are a technology company and we use super abrasives and our bonding technology to make that happen.
Okay, so the article is all about single layer tools. And whenever we say or refer to single layer, what we're talking about is brazed or electroplated super abrasive tool. And the main constituents of that are the blank, which will be the core. In most cases, this will be a steel core. The bonding matrix, which is what encapsulates all of the abrasive particles and retains them during the cut. This is what we call the bond. And then obviously the abrasive itself. This is a major detail, which can be diamond or CBN.
When we first started looking at these materials, the composites with the natural fibers, they act as a fairly soft material when they're cutting. So kind of the state of the art was PCD or carbide fluted tools for cutting the materials. The failure modes were mostly part edge chipping, and sometimes, depending on the type of cut, this was causing rejects in the line. If it wasn't caught right away, it could be multiple rejected parts. Initial single layer tools, we saw life that wasn't quite desirable due to the tools loading up, which is how they were reaching the end of life. So the thought was, we've removed the chipping and have the potential to reduce rejects. Now we just need to extend the tool life to make that economically viable. And I think you'll see we got to some pretty good results.
So in a single layer tool, there's different features that we can tailor, depending on the application at the time. Those are abrasive size, shape, concentration, and bond height.
Yeah, we'll talk to the next one.
Okay.
And that way we'll go into a little more detail. Now with those levers that we have available, how do you use that to design the tool? Well, what we found in these materials are you want to select the largest diamond size that you can for the application. Now what contributes to that? There are really two things. The edge finish that's required, because that's going to be driven by the particle size, and then feature size. Of course, larger diamond, we're going to have larger corner radii on the tool, larger chamfers, and all of that. So if there's small features, we have to tune the diamond to this. The next one that was kind of the biggest deal was the abrasive concentration. And that's the amount of abrasive that is on the tool. We generally gauge that as kind of a percentage. In the previous slide, you saw the bar there showing the examples of what we call a 3 or 30%, a 5 or 50%, 7 or 70%, and then a 9 or what's your typical full concentration on a tool. That's just a sample of what we can do. We would again want to tune that based on the application, which gets into speeds and feeds, coolant, and again the property of the material itself. Abrasives, aside from size, come in a variety of shapes. Everything from material that looks like a cube, so a block, down to shards that look like broken glass. Cubes, of course, tend to be tougher, so can last longer. However, the sharper tends to cut more free. So tuning that to this material, you're leaning toward sharpness with some balance for strength so that the crystals don't just fracture during cuts. Bond height, again, we want clearance because we want to avoid loading. So we want to be as low as possible to keep the diamond grains attached to the core until we get to where the failure mode is the diamonds wearing down, not fracturing, or the tool not loading up. So those are kind of the adjustments we use. One point we did make in the article is we've used both the common electroplated system for making this type of tool and the braze bond system. With braze bonding, you can drop the bond height further than you can with the electroplated system. Electroplated, you only have to rely on mechanical entrapment of the diamond grains to the steel core, whereas with braze, you actually get a chemical wetting on the diamond plus the mechanical entrapment, which lets you go, 10 to 15% lower in bond height in most applications than you can with an electroplated bond.
So this was an example of an opportunity that we came into. Customer was using a PCD tip saw blade for cutoff operation in natural fiber composite, and we rolled out a PBS, a brazed diamond version of the saw blade. And in the initial rollout, we essentially matched the curve, matched the diameter, and all of the basic parameters. And this is what we ran into. The failure mode of this saw wasn't the wear of the abrasive. It was the loading, caused rubbing and burning. It's not the failure mode that we want to see that's going to get long life out of the tool. The reason for using diamond in the first place is because its wear surface is much longer than PCD or carbide. So we review the application, look at the materials, look at these kind of failure modes, and then make manufacturing adjustments or spec adjustments to the abrasive size or shape or bond. And in this case, a combination of these things, especially concentration, and dialing back that concentration from the saw blade that you can see on the left side versus the saw blade that you can see on the right. These are made at vastly different concentrations, and this is really the key factor that we can apply that makes it work with these kind of soft materials. So in this case, the baseline number of cuts for the PCD saw was only 40,000. After we got the diamond saw dialed in with the proper bond and concentration, we went to 450,000 cuts. So, and with a different end of life, on the part side. So instead of when that PCD saw got dull and chipping out the material, now the customer was able to, like at the end of life, they had a slight burr at the edge of the tool, which could be just deburred, and it didn't lead to a scrap part, which also meant that now instead of leaving an extra 3/4 of an inch for this rough cut, now they can reduce every cut to 100 thousandths of stock. So many savings in linear inches through the 450,000 cuts that this saw made. And we actually have a case study that's available in the handouts page for download. This is just a summarized version of it. So you can download that and call us about it if you want to know more information or see how it could apply to an application that you have.
As we were getting more and more of these tools in the field, we started to get feedback on other issues that this product was helping with on the environmental health and safety side. One was when you're changing a PCD or a carbide saw, these are 16 to 20 inch diameter saws. Usually they have some weight to them. And so PCD and carbide, you need the Kevlar anti-cut gloves so that you don't tear your hands up. A grit diamond saw, you would be hard pressed to cut yourself on the saw. The gloves are absolutely not required to handle the saw. So potential reduce in injuries. The other comment was, wow, you can actually have a conversation standing next to the saw with the diamond saw running, whereas that was very hard to do with the carbide or the PCD tip saws. We're going to do some more data collection on that and see if we can quantify it a little bit better on what that noise drop is. I don't know if it's enough to potentially get away from having to wear earplugs, but at any rate, from standing next to the saw, it's significant. The other thing is we've gone into places and seen saws that have broken teeth on them because somebody mounted the saw in the wrong direction of rotation, and on a PCD or carbide saw, that's not really good for the saw. A grit diamond saw does not have a directional rotation. It will cut either way. The other thing was, because we're now making more dust than chips, it was easier for dust collection systems to pull the material away, so less cleanup around the equipment itself and more of the particles being generated being evacuated by the dust system.
Okay, here are some photo examples of different shapes of tools. I think in general, we talked about saw blades, and the case study is all related to saw blades. But the cool thing about this technology and the way we apply it in manufacturing is that we can put it on pretty much any shape. And here you can kind of see some different like slotted, kind of router style tools, some tools that can replace like a PCD stacked cutter head, and even things that can be what's more similar to a diamond or CBN form wheel. We can hold pretty good tolerances through a process like this, and we can still hold good tolerances on features. So there's a lot more applications than just cut off saw blades. And I think here's our contact information.
Yes, and that was really kind of our quick summary of the article. Hopefully we'll have some questions here that we can answer.
I'm going to share just a couple of questions that came in during the webinar process, registration process from some of the attendees in advance of today's event. The first question is, how important is high pressure, high velocity coolant delivery?
And I'll take that question. In these materials, most cases, we've been dealing with dry grinding, usually because they don't want to do a cleanup operation after the grind, or there's worry about contaminating the material. That said, high pressure coolant can greatly improve the life in about any application with a single layer diamond or CVN tool. Some things we found is that if you are going to use a coolant, if it's a water soluble coolant, you really want to be with the coolant velocity in the range of 90+% of your wheel periphery speed for the coolant to be effective in being carried through the cut. If you're using a straight oil, that velocity can be down as low as 60% of the wheel speed and still be effectively carried through the cut to extend the wheel life. And that's really what the coolant is going to do, is going to extend the wheel life. As I said, in a lot of composite materials, we can get away with dry grinding. Another coolant to use is just a cold air gun. Again, really your coolant is there to extend the life of your tool. In most metal grinding applications, you're correct, you're going to need a good high velocity coolant to use a single layer CVN tool in metal grinding and shaping.
Okay. Another question that came in, when do electroplated wheels need to be indicated in during mounting?
Okay, I'll take that one. So in general, I mean, if the more you can reduce run out in the wheel, the better it's going to wear, the better it's going to run, lower vibration. The wear pattern is going to be even around the circumference of the wheel. When we make a wheel, we can make the bore tolerance tight enough that you can mount the wheel without doing any indicating. That kind of is dependent on the how precision the spindle is that it's going to go on. But if a wheel needs to be have a little bit of a looser fit, it's very normal for us to put an indicating feature onto the front face or some surface of a wheel, based on whatever your specification is, and the bore, the form, the OD of the wheel, and that indicator are all going to run concentric to each other. The other option is if the wheel is going to mount to a specific type of arbor, like an HSK or any machine specific arbor, we can mount that wheel onto the arbor itself here, indicate it, and potentially even balance it ahead of sending it out. So it really is kind of dependent on what your setup is and what your spindle is. And there's some other factors, the more close to roughing the application is, the less of an influence, a perfect indicated surface is going to have. But if you're doing high precision finishing work, you want it to be tight. So.
Okay. At this point, I'm just going to go to any questions that come in from our audience. There was one that has come in already, and I just want to take a second to encourage anyone else out there who has a question of any kind, just go ahead and type it in and submit it. But the question that came in during the presentation that you were giving, by the way, just asking, can you stick a plated wheel with a white stick to clear out loading?
And the answer to that is yes, you can. What we have found more effective to clear loading is a stiff wire brush because it better gets in between the abrasive grains. A grit diamond tool will cut aluminum oxide stick really efficiently, so it tends to cut it away faster than let it get down in between the grains to really be effective at removing the loading. Like I said, it will do some. The wire brush will do you better. The other thing we've had is if the wheel is loading up a little bit, these wheels, since it's a steel core and especially the brazed bond, can take 1,000 and 1,100 degree temperature without any problem. We've had people that have had bake-out ovens that will get warmer or warm enough to basically burn whatever the binder in the material they're cutting is. So they put it in the oven for a half an hour or so, take it out, let it cool down, and then the material very easily brushes off. We have had other people that know what solvent it is that will dissolve the base material, and they've either solvent dunked it or used a brush and solvent cleaned it. So those are the methods we've seen that can be effective in removing the loading.
Great. There are no other questions that have been submitted yet, but I just wondered if you, Tom or Jeremiah, if you wanted to address any of the questions that you're getting about the product that's been out on the market for a bit now. So any top challenges that you want to kind of share with us?
Well, one thing that we've run into several times is that some of the machine tools are geared where your spindle RPM governs your feed rate. And so to get to the feed rate they've wanted, they've had to run at very high RPMs. And that's where, and we didn't have it in the summary, but it's in the article, we have seen that on the plus side of 18,000 surface feet per minute in these materials, you can get burning very quickly. I mean, that surface speed, you're just putting a lot of energy into the system. So it's caused us to do things like we're running up against that top end, further reducing the concentration to help reduce the rubbing and heat generation. That's where having a cold air system on the wheel, if you need to run that fast, becomes beneficial at now getting some of the heat out of the system. The other thing we found is on the lower end, you'll read a lot of literature that says single layer grit tools shouldn't run below 4,000 or 6,000 surface feet per minute. We've had applications running below 1,000 surface feet per minute on the tool, especially the small router that was in the center there of our page. That lower section was a little over 1/4 of an inch in diameter, and then it does angle out. It's tough to get that to 4,000 surface feet per minute. You just have to balance your speed rates and depths of cut, and the tool can be very effective. One other thing that kind of wasn't in the article and is kind of a summary about abrasive technology, most of these tools were in from the time the tool has been designed, we've agreed, the drawing's been signed off, we're 3 weeks, sometimes less, maximum maybe 4 weeks on delivery. And repeat orders are in that 3 to 4 weeks from receipt of purchase order on the tools. So a lot of times it can be an issue with needing tools fairly quickly. We have pretty good lead times, and can't even beat that if necessary.
Okay. We did get another question, and I just want to get to that. The question is, can we use a plated CVN wheel with water-based coolant? Are there any issues with that?
Yes, you can. We've done a lot of work with that. You're going to need a good coolant system. That's something I mentioned in kind of the first question, this kind of continuation of that. The CVN wheel doing a metal grind and a water-based coolant, you're going to need to be able to get that coolant velocity up to 90% plus of the wheel speed. That can be a challenge. The water-based coolants don't really want to cling to the wheel. The other thing is a lot of the newer water-based coolants are going to lower and lower additives and lower sulfur levels, which means your velocity and aim are even more important to make the wheel function properly. The other thing is, with good coolant, good aim, and optimum conditions, if you took the same system and switched it to oil, you're going to get 40 to 60% greater wheel life. So can you make a water-based system work? Yes, you can. Can you make it work enough for it to be economical rather than going out and buying another machine that's fitted to run oil coolant? Yes, we have quite a few people that are doing that currently. Ken, we'd want to get into the application details, and please contact us and we can help you work through all of that.
Okay. Why does water-based, another question, why does water-based coolant have problems with plated CBN? Why is oil better?
It really is the two things are, one, oil has a better ability to grab onto the wheel to be taken through the cut because it's typically more viscous. The other thing is oil is a much better lubricant. There has been the argument that water is better at getting out the heat, so it should be as good as oil. Well, the problem is with oil, you have much better lubrication, so you generate less heat to begin with. With water, because you don't have as good a lubrication, you're generating more heat, and it's not an even trade-off. So that's why it is more difficult to work with water-based coolants with single-layer wheels.
Okay.
Again, not impossible, but it is more difficult.
Okay. Well, I don't have any other questions, and take another minute here just to let anyone else submit a question. If there's any other aspect that you want to go back to or touch on, we have some time, but it's up to you.
Yeah, I guess I was just thinking in general about the initial question that came in about how important is high pressure, high velocity coolant. And I was just kind of wondering if maybe that person wrote the question related to the article or related to everything we've been talking about here. And like Tom mentioned, in a lot of these composite applications, either the machines won't be equipped for it, or people just don't want to use coolant for many reasons, contamination or anything else. And that's actually that's a decent part about the application, and that's a reason why we can do the tailoring of the tool for that. We're kind of working around the inability to properly cool the material, so that's when we can go in and back off the concentration and allow more room for heat and swarf to escape the material or escape the cut zone by not by having to use coolant, but by tailoring other factors on the tool. So it can be important, but it really depends on, even though it might be important, there's good ways to work around it in certain materials.
And yeah, like I said, that is a good point. And if they really wanted life and went from 40,000 cuts to 450,000, that was all dry with decent coolant on there. Who knows, that saw could potentially reach 800,000 cuts. But again, then there's the downside of the coolant of having, if the machine's not equipped to do it, now you're buying new equipment. If it means extra cleaning processes that you're incurring cost upstream. So yeah, we can see why in these materials there's a lot of reasons to not use coolant.
You guys are making a pretty good team here. Have you written the other articles like this before? Are you out there doing any sort of presentations that the audience might want to know about?
We do, mostly it's working with an individual customer. And it will either be Jerry or myself, or there are a lot of times where it's, both of us. Like I said, I've been doing this for quite a few years, but it's amazing how often I run into something that I have to go, wait a minute, I haven't seen that before. We're really going to need to talk about it and see what we can do. And I guess that's the point. Probably that's a very good point to make. There are so many different materials and types of applications out there. And because we can tailor our tools, it's one of those, we really don't want to say no until we really understand the application and get the details of it. Even if it isn't a single layer application for us, because Abrasive Technology also has bonded tooling, and we do make PCD tooling as well. But again, for this application and these materials, we selected our single layer bonds and tailoring the concentration because they provided the best economics in that situation. We do, as a company, attend some trade shows. I believe they're at East Tech right now, West Tech right now. We will be at East Tech. So yes, the West Tech Aero Def show that they're at now. And then November 7th through 9th.
Actually, I think the West Tech is in a couple of weeks. I think you might be thinking of South Tech.
South Tech.
South
Woo,
Tech.
Thank you. I'm directionally challenged this afternoon. So
No, that's all right. I'm challenged with time zones.
We're good. So yes, we can be found at some trade shows.
Okay. Yeah,
it's more working on site with an individual customer, because a lot of the stuff is so application specific. That getting there and getting those details, and as I said, that is a service that we offer. Typically start out with a phone call or a Teams call, something like that, to start to get the basic information. A lot of times very quickly we can say, yes, this is a go, this is a fairly typical application, all the way to, we really kind of need to take a look at that.
good, very good. Well, I don't want to take up too much time. Well, we do have another question.
Oh, all right.
Are these solutions viable for strip and replates? I'm reading that right?
Yes.
Not the best.
Yes, saw blades, we're stripping and replating most of those. Some of the smaller tools, it's not economical to strip and replate them, just because we can CNC turn the blank so quickly that there's just not enough value in the blank to make shipping it back, having it stripped and replated viable. But the answer is, yeah, in most cases, yes, these tools can be stripped and replated to bring additional cost savings.
Do you do that in-house?
Yes, we do that in-house.
Perfect. I was just going to say, if wait another minute, I guess, to see if there's any other questions, but there's no reason. Everyone's here on a lunch hour, or like right around the lunch hour, and in the interest of their time needs, if there are no other questions, we can conclude the webinar early and can open it up to any final comments for Tom or Jeremiah, if you want to add anything.
Just say thank you all for your time today. Like you said, probably taking time out of your lunch hour. And probably the biggest thing is use the contact information, get a hold of us. We're happy to discuss your applications with you, find out if we can help you. And if not, at least we can point you on what we think the best direction is.
Yeah, thank you. This has been really good. And I hope that we get some contact from this and we get to talk to people about some new applications. Because we're happy to, take everything from original tool design, replacing something, a current implementation that's not a Diamond tool, or looking at your current Diamond application and maybe switching it over to a PBS tool that, could be much better tailored for it. Tom or I will, we'll be the ones reviewing that, so you can call in and talk to us directly.
Perfect. One of the things that we're at CTE that we're doing is trying to give our audience, the magazine and online, give our audience an opportunity to talk to the contributors to articles, whether that means like you, that you authored the article, or we've interviewed someone and they're, a source in one of our articles. And so this is kind of the beginning of that concept, and I hope you've found it enjoyable to do this, and I think our audience appreciates it as well. So I appreciate your taking the time. Tom, Jeremiah, you guys, I think, did a great job. Really appreciate your participation in this, and I hope we can do it again sometime. As to the audience, thank you for your time. I know you have jobs that you got to do, and this is taking time away from that. So thanks. With that, I'm going to leave this contact screen up for about another minute, but I'm going to close out of the webinar, and I appreciate everyone for attending.